Okay, let's continue the discussion about quadratic equations. Remember, in the last video, we learned the square root method. Square root method. Let's see, focused. Focused. How to make it a focus? What? The square, let me write more words. Square root. What's happening? Okay, square root method. Okay, so square root method, the last example was like this. If we have a quadratic equation like x minus 2 quantity squared is equal to certain positive number, then what did we do? We just take square root, we get x minus 2 is positive square root of 16, or x minus 2 is negative square root of 16, right? And then square root of 16 is 4, right? This is negative 4. And then we solve two linear equations. X minus 2 is 4, or x minus 2 is a negative 4. So x is 6, or x is negative 2. Just move 2 to the other side, it becomes plus 2. So negative 4 plus 2 is negative 2. 4 plus 2 is 6. All right? So if we can transform whatever quadratic equation into this type of a form, then we completely solve it. Right? So we are trying today's example. We are trying to transform or rewrite a quadratic equation into such form. This is a solve second part. A quadratic equation by completing the square. Completing the square. Completing square means we're trying to make a quadratic function looks like this. Okay, so before we do the completing square, let's check one formula. If we expand a plus b quantity squared, you just do product. I'm going to do one time only. So it's a times a squared, a times b, ab, b times a, ba is ab, b times b is b squared, right? So it's just one by one multiplication. And then you combine these two are the same thing. So you get a plus b quantity squared is a squared plus 2ab plus b squared. And the corresponding part will be a minus b quantity squared. You do the same computation. It is a squared minus 2ab plus b squared. Okay, so completing square method is based on these two functions, these two formulas. Okay, so we are going to use example to see how do we apply those two formulas. Example, solve by completing square. Solve by completing the square. X squared plus 5x plus 4 is equal to 0. Okay, so here's what we are going to do. So first we copy this function, equation. We copy this equation, and the first step, we're going to move the 4 to the right, to the other side. So x squared plus 5x is equal to negative 4. We always move constant term to the other side, to the right side. And second, you see, x squared, a squared, this is plus, we're going to use the first one. X squared, a squared. So in the formula, a is x. And then in the second term, we need the number 2, factor 2. But here there's no factor 2. So we are going to do the following thing. We artificially put coefficient 2 here. A is x. Remember, A is x. So here's x. Then what's next? Here you have 5, but you don't have 2. So you just divide 5 by 2 to balance this so that this whole thing is still 5x. You see, you artificially put 2, and you see what x here? The first one is x, you find x here. And then you're trying to justify the third term so that the whole product is still the original 5x. Okay, so you have 2, so you have to divide 5 by 2. So you get 2 times x times 5 over 2. So this quantity is still 5x. And then you see this is A, this is A, this is number 2. Then this 5 halves must be B, 2AB. Then you need B squared. So I'm going to add B squared. So equal. The right hand side is -4. You add B squared in the left hand side. You will also add B squared in the right hand side to balance it. Okay, so this is a crucial step for the completing square method. So you need artificial 2, coefficient 2. You have x, then by the proper number, you can determine b. So usually this number is going to be the coefficient divided by 2. And then you are going to add this b squared. This is b squared. You add b squared in the left hand side, you also add b squared in the right hand side to balance it. -4, you copy -4. Okay, so once you get those three terms is equal to a plus b quantity squared. So a is x, so it is equal to x plus b is a 5 halves squared. Right hand side is -4 plus 5 halves squared is 25 over 4. -4 plus 25 over 4 is, you see, -4 is -16 over 4. 25 plus 25 over 4 is 25 minus 16 is 9 over 4. Okay? So you see, if I write one more step, you see what we get. We get what we like. Some quantity squared is equal to a positive number. Only left hand side contains x, right hand side just a plain number. Okay? And once you get this form, you can apply the square root method. You take square root, you will get x plus 5 over 2 is a positive 9 over 4, which is a 3 halves, or x plus 5 halves is equal to negative square root of 9 over 4, which is negative 3 halves. And then you solve these two linear equations, you will get x is either 3 halves minus 5 halves is -1, or negative 3 halves minus 5 halves is -4. So the solution set will be -1 and -4. All right, so this is completing the square method. Completing the square method. Okay, so let's see what's next. Let's see another example. We still try to use completing the square method. 2x squared minus 8x minus 5 is equal to 0. So how do we solve it? Let's see what was the first step. We move the constant term to the right hand side. We move -5 to the right hand side, it becomes +5. In the first example, x squared has no coefficient, no other coefficient. Here it has 2. So we're going to divide this equation by 2. I don't want any coefficient attached to x squared. We divide this equation by 2. Divide the equation. I do want the just x squared. And then you see this is x squared, like the a squared. And then we need, this is minus, so we need the second formula, a similar thing. So you will have x squared minus 4x, and I need to multiply this term by a proper number, 4 over 2. Because here you multiply it by 2, so you're going to divide it by 2. This is your b. It's 2ab. See it? And then here, this is b. 4 over 2 is 2. b, then you need b squared. b squared is 4. This is b squared. Then 5 halves plus also b squared. This is also plus b squared. You add b squared on two sides. See it? So actually here you can always see that this number is half of the original coefficient. It is half of the original coefficient. Okay, so a squared minus 2ab plus b squared. So the left hand side becomes a minus b quantity squared. So it's x minus 2 quantity squared. The right hand side, it's 5 over 2 plus 8 over 2 is 13 over 2. It's 13 over 2. Okay, so this is a form, the form we like. We can take square root of two sides directly, so we get x minus 2 is a positive square root of 13 over 2, or x minus 2 is negative square root of 13 over 2. And then you solve these two linear equations, you will get x is 2 plus square root of 13 over 2, or x is 2 minus square root of 13 over 2. That's it. So you can write down the answers, the solution set. Is 2 plus square root of 13 over 2, 2 minus square root of 13 over 2. Okay, let's see two more examples like this. Let me find the practice. Okay. I see on page 101, problem 38, we like x squared plus 2/3 x minus 1/3 is equal to 0. Okay, so we are going to solve it by completing the square. Remember, we are practicing this process. So we first move negative 1/3 to the right hand side. In this process, I don't care if it is a rational number or integers. It doesn't matter. What I care is that the first x squared term has no coefficient, no other coefficient. So x squared plus 2/3 x is equal to 1/3. And then you see I'm going to have 2x 1/3. 2x times 1/3 is exactly 2/3. This number is actually 2/3 divided by 2. 2 cancel this 1/3. It's just half of the coefficient. Half of a coefficient. And then you square it. You plus 1 over 9. You also add a 1 over 9 in the right hand side. In the right hand side, you also add a 1 over 9. These two numbers are balanced, but we need it in the left hand side in order to complete the square. And this is x plus 1/3 quantity squared. This is a 4 over 9. It's a 4 over 9. And then you take square root, you will get X plus 1/3 is 2/3, or x plus 1/3 is negative 2/3. 2/3 is square root of 4/9. So x is 1/3, or x is negative 1. You see it? So this extra number is always half of the original coefficient. Always half of the original coefficient. Okay, let's do one more example. This is 38. Let's see 36. I'm trying to select the even number because they do not provide answers for the even number. Okay, x squared minus 6x is equal to 13. This number 13 is already on the right hand side, so that's it. And 6/2 is 3, so we get x squared minus 2x times 3, 2ab. So b is 3. b squared is 9, so 13 plus 9. 13 plus 9, what is this? 22. Okay, so it's x minus 3. Remember, here this is a 3. Squared is 22. So x minus 3 is positive square root of 22, or x minus 3 is negative square root of 22. So x is 3 plus square root of 22, or x is 3 minus square root of 22, and that's it. You see, once you get completing square process, the problem is not difficult, very fast. You can do it in a very fast way. And the completing square process is not tricky. You have fixed the step. It's not like the factorization. The factorization is actually sometimes tricky. You have to really know how to properly factor the numbers. But completing square, just go through it. Get 2, divide the coefficient by 2, and get b, and add b squared, and that's it. Okay, so such very fixed steps can always be computed by computer, or can be used to generate formulas. So the third part, we're going to get so-called the quadratic formula. Solve a quadratic equation using the quadratic formula. If some method is tricky, then you may not be able to apply it to the computer. But if some method is very rigid, you have to do it step by step. By this step, by that step, everything will be fixed. It can be done by computer. Once it can be done by computer, it means there is a formula behind it. Okay, so now let's look for the formula. How do we get a formula? The whole process is not required, but the final formula is required. Okay, so I'm going to prove or find the formula. This research is not required. The future formula is required. Okay, so we have a quadratic equation in the standard form. What did we do? We first move c to the other side. This is how we did. And then we divided the whole equation by a, so that x squared has no coefficient. We can do this division because a is not 0. A is not 0. Okay? Okay, and then remember, we need a coefficient 2, and then we have to divide this coefficient by 2. Remember that? That's the tricky part. So we have 2x. b over a divided by 2 is b over 2a. You see, this 2 cancel. You still have b over a times x. And this is going to be the second term in the formula. And then we need b over 2a squared. We add this quantity in the left-hand side. We're going to add it in the right-hand side. Well, this step, it just looks complex, but this is exactly how we add 9. If we get concrete numbers, they are not such complex, right? We'll add 9. And the right-hand side becomes x plus b over 2a quantity squared. On the right-hand side is negative c over a. This is b squared over 4a squared. b squared over 4a squared. And then, let's see, negative c over a is negative 4ac over 4a squared. I'm trying to find the common denominator. 4a squared is the common denominator. So I multiply c over a, top and bottom, by 4a. And then this right-hand side, I'm trying to simplify the right-hand side. It's a 4a squared. Then this is b squared minus 4ac. Okay. Well, again, this formula looks very, very complex, but this whole thing is exactly the 22 in the concrete example. We just try to make the concrete formula, concrete numbers by the complex formula. Abstract. Okay? So again, this whole process is not required. Later we will see the formula. Well, let's do a little bit discussion. 4a squared is always positive. But b squared minus 4ac may be positive, may be negative. Not use a letter A. First case, b squared minus 4ac is negative. If this numerator is negative, divided by a positive number, the right-hand side becomes still negative. Right? If the numerator is negative, denominator positive, the ratio is still negative. A square is equal to negative number, the equation has no solution. We will see example with such case. All right. So when b squared minus 4ac is negative, there's no solution. When b squared minus 4ac is non-negative, then this ratio will be non-negative. We can take square root. Only when this happens, we can take square root. We take square root, we will get x plus b over 2a is equal to square root of b squared minus 4ac over 4a squared, or x plus b over 2a is equal to negative square root of b squared minus 4ac over 4a squared. Over 4a squared. Okay? Well, 4a squared is exactly 2a quantity squared. You can move it outside. When you move it outside, you have to be a little bit careful when a is positive or when a is negative. When it's a positive, move outside is 2a. When I'm saying this is correct if and only if when a is greater than or equal to 0. When a is less than 0, you will have a negative sign. So, but here you have one is positive, the other one is negative. So eventually you will have two answers. You don't lose anything. So that's why in the book, they only discuss the case when a is a positive, greater than 0. In the textbook, they always assume a is a positive. If a is a negative, you multiply it by a negative 1 and make it positive. But anyway, just remember or be careful, there is a small issue about the sign, but eventually you will always have a plus or minus. So assume this a is a positive, not equal, there's no equal case. Assume this a is a positive, so we can take square root b squared minus 4ac over 2a, or here negative b squared minus 4ac over 2a. We can move this 4a squared outside of the square root. And then we move this b over 2a to the right hand side, b over 2a to the right hand side. So we will get our formula. X is negative b over 2a. Here's plus, here's minus, plus or minus square root of b squared minus 4ac over 2a. Right? They have the common denominator, so we just write in the one formula. 2a negative b plus or minus square root of b squared minus 4ac. And this is called the quadratic formula. This is so-called quadratic form. This formula works for a positive. It also works for a negative. There's no difference. Okay? So the whole process is like this. This is exactly the repeat of the concrete example, but we just use letters to represent. Okay, so again, let me officially introduce this. Consider ax squared plus bx and plus c equal to 0. Here a is not equal to 0. Again, this formula works out for a positive. It also correct for a negative. There is a small issue when you move this 4a squared outside of the square root. Plus or minus sign will give you the same formula. Okay? So here, when we state the theorem, we don't assume a positive. One is negative. This is still correct. Okay, consider this quadratic equation. We have two cases. If b squared minus 4ac is negative, there's no solution. If b squared minus 4ac is greater than or equal to 0, the solution or solutions are given by x equal to denominator 2a negative b plus or minus, there are two solutions in general, b squared minus 4ac. b squared minus 4ac. This is called the quadratic equation, the formula, sorry. Quadratic formula. The quadratic formula. Okay? If b squared minus 4ac is equal to 0, plus or minus 0 is nothing, so you will have one solution, one repeated solution. If b squared minus 4ac is exactly greater than 0, like that 22 stuff, then you will have two different solutions. One is a plus square root, one is minus square root. Okay? And because this quantity controls the number of the solutions, so this b squared minus 4ac, this quantity is called the discriminant. Discriminant of the quadratic equation. discriminant of the quadratic equation. Okay. The discriminant of quadratic equation will control the number of the solutions. Will control the number of the solutions. So, discriminant of a quadratic equation. Case 1, b squared minus 4ac, positive, two different real solutions. b squared minus 4ac is equal to 0, one repeated solution or one double solution. b squared minus 4ac less than 0, zero solution. Zero solution means no solution. Oh, in other words, no solution. Okay, that's a discriminant of a quadratic equation. Discriminant of a quadratic equation. So after you study this quadratic formula, whenever you have a quadratic equation, you will possibly verify or check this discriminant first. You're going to compute this number first. If this number is negative, then you don't bother to solve it. It has no solution. If b squared minus 4ac is a negative number, then you don't have to compute it or solve it because it has no solution. Okay? So for example, if we have 3x squared plus 2 is equal to 4x. Be careful, this discriminant is based on ABC. ABC can only be determined in the standard form. You have to write the equation in the standard form in order to find ABC. Okay, so for example, if you have 3x squared plus 2 equal to 4x, it is not a standard form, so you cannot read ABC in this form. You have to move this 4x to the left-hand side. You get 3x squared minus 4x plus 2 equal to 0. Then A is 3, B is, be careful, B is negative 4, and C is 2. Okay, A, B, and C. And then you compute b squared minus 4ac. b squared, negative 4 squared, 16, minus 4. 4 is 4. A is 3. C is 2. 4 times 3 is 12. 12 times 2, 24. So it's 16 minus 24, which is negative 8. Okay, it's negative. What happens if discriminant is negative? No solution. So the equation has no solution. The equation has no solution. All right. So you first verify this discriminant. If it is negative, you are done. No solution at all. And also, to determine A, B, and C, you must use a standard form. Okay. Let's see another example. So try to solve 3x squared minus 5x and plus 1 is equal to 0. So we know A is 3, B is negative 5, and C is 1. So first you examine B squared minus 4 is C. B squared negative 5 squared, 25 minus 4A and C. Well, 25 minus 4 times 3 is 12. So the difference 13, positive. So when the discriminant is positive, you will have two different real solutions. Okay. Then x is negative b plus or minus square root of b squared minus 4ac over 2a. Remember, what is b? B is negative 5. Negative b is positive 5 plus or minus square root of b squared minus 4ac. We just compute. It's a 13 over 2a. A is 3, 2a is 6. So the solution set is 5 plus square root of 13 over 6 and 5 minus square root of 13 over 6. And that's it. That's it. That's it. So you see, very, very fast if you memorize the formula correctly. All right. So this one has two different real solutions. The first example has no solution because the discriminant is negative. Okay, the next we're going to solve this equation. 25 over 2 x squared minus 30x and plus 18 is equal to 0. Well, when we solve quadratic equation using the quadratic formula, it doesn't matter if you multiply this equation by any number. We can start from this original form, determine A, B, C, compute the discriminant. Well, let's do it in the original way, and then we do it in the after we multiply something. Okay, with these original numbers, A is 25 over 2, B is negative 30, C is 18, so B squared minus 4AC is going to be negative 30 squared, 900. Negative 30 squared, B is negative 30. Okay, keep this in mind. A squared is 900 minus 4AC. Okay, so you see, 4 times 25, 4 quarters is 100. 18 over 2 is 9. 9 times 100 is 900. 0. Discriminant b squared minus 4ac is equal to 0. Then we know there is a double root. So right? You are going to plus or minus square root of 0. Plus square root of 0 is plus 0. Minus square root of 0 is still minus 0. So it is a double root. Double root b is negative 30. Negative b is 30. 2a. 2a. So 2 cancelled. It's a 30 over 5 is 6 over 5. So the double root is 6 over 5. Its solution set is just 6 over 5. All right? Okay, so this is the computation when we keep this denominator 2. Of course, remember when we started the discussion about the equation, we said we don't like the rational numbers, we just want the integers. So we can multiply this equation by 2 to cancel this denominator. So just multiply two sides of the equation by 2. All the terms multiplied by 2. So 25 over 2, 2 cancelled. 30 times 2, 60. 18 times 2, 36. And in this case, A, B, C are changed. Okay? So in this case, this is A, this is B, this is C. So you have B squared minus 4AC. B squared, this B is negative 60. So its square is 3,600 minus 4A and C. 4 times 25, 100 times 36 is 3,600. Still 0. Still 0. Discriminant, that's not determinant. Discriminant is still 0. It means the equation still has a double root. It has a double root. Then you have x equal to negative b over 2a. When you have a double root, it's always negative b over 2a. It's always like this because you are going to plus or minus 0. And this time b is a negative 60. Negative b is 60. 2a is 25 in this case, so it's a 60 over 50. 6 over 5. See? Exactly the same thing. Exactly the same thing. So it does not matter if you transform a rational number into integers. It doesn't matter. You will get, you're supposed to get the same answer. So if you use a factorization method, you may choose multiplying two sides by integer bigger denominator so that there's no rational number. But if you choose to use quadratic formula, then it doesn't matter you multiply it by 2 or not, you will still have the same answer. Okay. Next, sometimes this equation is not originally given as a quadratic equation, but it can lead us a quadratic equation. So first of all, let's see. We have 9 plus 3 over x minus 2 over x squared is equal to 0. Of course, x appears in the denominator. X is not equal to 0. Well, first of all, this equation is never a quadratic equation. But after simplification, we will see it is a quadratic equation. So what we are going to do, we're going to multiply this. It has denominator x squared. So we multiply two sides by x squared to cancel the denominator. So we simplify it. We multiply two sides by x squared, then it becomes 9x squared plus 3x minus 2 is equal to 0. It's like we try to eliminate the denominator. Okay, so now it becomes a quadratic equation. Quadratic equation, first you check b squared minus 4ac. B is what? B is 3. 3 squared is 9 minus 4ac. And be careful, c is negative 2. C is negative 2. So it's a 9. So minus is plus. 2 times 4 is 8. 8 times 9 is 72. 81. Greater than 0. Greater than 0 means it has two, it has what? It has two different real solutions. It has two different real solutions. So in the root formula, x is negative b plus or minus square root of a b squared minus 4ac over 2a. B, what is b? B is the 3. Negative b is negative 3. Plus or minus square root of b squared minus 4ac. Actually, we will use this number when it is not less than 0. Okay, over 2a. A is 9 over 2a. 2a is 18. Square root of 81 is 9. So x is negative 3 plus 9 over 18. What is this? It's a 6 over 18. It's 1/3. Or x is equal to negative 3 minus 9 plus or minus. You have two choices. It's negative 12 over 18 is negative 2/3. You cancel 6. Okay, so you have either this one or this number. So the solution set is negative 2/3 and 1/3. Negative 2/3 and 1/3. Right? So this is a solving equation that lead us a quadratic equation. Remember that we have a similar part, a solid equation that lead us a linear equation. Okay? So next, we'll have one more example. We'll finish this section. This is an important formula. Okay, let's see the next problem. Let me make it bigger. Okay. See if I can make it just. Okay. So example: constructing a box from each corner of a square piece of sheet metal. Remove a square of side 9 centimeters. Turn up the edge to form an open box. If the box is to hold 144 cubic centimeters, what should be the dimensions of a piece of sheet metal? Okay, let's see if I can give you the shrink a little bit. Okay, not solution. Solution is not. Okay, yeah. So here, this one. You have a big sheet metal. You're going to remove 3 small pieces. You're going to remove 4 small squares from each corner. Okay, and after you move it, you will get this cross, and then you fold up to form such open box. And they want this open box to hold 144 cubic centimeters. They want to know what is the dimension of the large metal sheet metal. Okay? Okay, I'm going to rotate my camera. If you don't remember it, and stop the video and read it again. Okay, so the problem is like this. Let me repeat. I have some metal sheet which I don't know the dimension. I'm going to remove a 9 centimeter squares from each corner. Okay, after I remove them, I will have. Do I have enough? I will have those of a cross. and you fold 4 pieces along this red line to form a box. This box should have the volume 144 cubic centimeters. They want to know what is the dimension of the original sheet. Okay. So because they don't know what is the dimension of the original sheet, so this is x. The box, where are those the box has the volume, area of the base times height. Area of the base, this is a square. After you remove 4 small squares from 4 corners, this internal stuff, this is base. It's still a square. Its side is this is 9, this is 9 centimeter. 9, 9, 9. So this side is x minus 9 minus 9 minus 18. So the base is x minus 18 by x minus 18. You fold up the cross legs, so this 9, this side 9 becomes a height. So the height is 9. So the base, area of the base times the height is equal to this 144. Okay, area of the base times the height is 144. A base is a square, so it's just a side square times height. And we divide two sides by 9, we will get x minus 18 squared. This one divided by 9 is what? It's 116. Okay. And this is exactly the square root method. You solve for x, you will get x minus 18 is square root of 16, or x minus 18 is negative square root of 16. So x is, you move 18 to the right side, 4 plus 18 is 22, or x is negative 4 plus 18 is 14. Well, you have two answers, but this one is incorrect. Why? X equal to 14 is not correct. Well, it is correct for the equation. This equation can have solution 14, but this problem, for the problem, why? You're supposed to remove squares with side 9 centimeters from each corner, so the total should be greater than 18. The side should be greater than 18 because the side of the sheet must be greater than 18. Right? Here's none, here's none. At least you should be able to remove 9 from each corner. So it has to be greater than 18, but this is 14, not greater than 18. This one is dropped, then you will have 22. So the side is 22. Okay. So that's it. So that is the answer. What is the dimension of the piece of a metal sheet? The piece of the metal sheet has side 22 centimeters, cm. 22 centimeters. This problem is difficult because you have to understand the geometry behind the words. Remember that you can read the problem in a few seconds ago. Okay, so you're supposed to understand the geometry and you're supposed to know how to fold it and stuff. In the exam, I will provide such graph, so you don't worry about this graph. Possibly, you have to understand where you define x. Okay, so we finished this section 2, and if you have any question, send me email. Do your recommended exercises. If you find any mistake I made during the lecture, also send me email. Thank you very much. We will continue in the next video. The lecture is not done. Okay, thank you.